Hello friends, today I'm going to share a really cool experiment about electrical circuits, and today this topic is about inductors. So here I have a very simple circuit with just a battery, a switch, some wires, and a full winded up coil and an LED light. So for this experiment, when I try to turn this on, you see there's nothing wrong here, it'll be just a boring thing, but when I turn it off, you see like a very quick flash on this LED, alright? So, here, I'm gonna put my hand here. Oh, that's my bad. Here. So when I'm gonna turn it on, you see, it doesn't, there's nothing. I'm trying to be honest, there's nothing here. Look, I'll do it. Here, I'm not gonna show the LED right now, I'm gonna do it again, just to be honest, alright? See, there's nothing wrong, alright? But when I turn it off, did you see that flash? I'm gonna do it again, just for the last time. Alright? Nothing. When I turn it off, you see that flash. So you might be asking, how is this? And I'm gonna explain that after I take this off on the table right now. Alright, I am back, yes, and I have a board with me to explain to you how it works, actually. So I made the simple circuit from the circuit that I showed you before, and I just made it into symbols. So here, this means the battery, this means the switch, if you can see it carefully, if you can tell. And this is the inductor that I was talking about that topic, and this is the LED light. So, there's actually two circuits that are together, but I'm just gonna say this is C1 and this is C2, right? Besides that, so how is it actually happening? To tell about this, we first, for now, let's make this closed. Let's make this, opened, to be honest. Opened, right? This C1 is open circuit right now. The C2 is a closed circuit, but there's no electricity flowing, so that doesn't mean anything. So, on C1, we're going to concentrate on C1 first for now. C1, what it does is when we make it on, meaning a closed circuit, electricity flows through here, we know, positive to negative, the current flow, not the electron flow, current flow. Current flow will go through here, but we know that that's a coil, right? If there's a coil, that means it creates a magnetic field. So that means that's an electromagnet. But this type of coil, probably any coil, but not like the coil that I showed you last video, like about like the electromagnetic. But right here, what I'm saying is that when it gets to here, it creates that magnetic field, yes, and that magnetic field creates that difference. It gets to like somewhere that creates more. It's like a you don't say like a difference. How would I explain it? It's like there's a change. You say a change, right? A change. There's a change to the magnetic field. And that means there's this opposing force called back EMF, or in other words, counter electromotive force. Meaning it'll be opposing the force. But that's a fraction of a second, so you wouldn't see it in real life. So don't try doing that if you're going to do something like an experiment like that. I don't know if you're going to do it. But besides that, so when it does, but since the battery is constantly pushing more force, it let the back EMF fades away, and then now it flows. Oh, that's a bad arrow. And then back to here. But we're not just going to let this keep on going, probably. It's just going to be a waste of electricity, I mean. So, that's how it goes for C1, alright? C1 is like that. It creates that the change of magnetic field, when it's created, and that creates that back EMF, or counter electromotive force. You can try to remember that, or you just remember back EMF. But besides that, now, we're on to C2. C2, what it does is that when I make it an open circuit to C1, what it does is that now with that electro flow, it now acts like a battery now. Because now the magnetic field is now is creating that voltage, and now it's trying to create that change again. From the high to low. So that means it'll create another back EMF to this side. So it doesn't go this way. This is a big no-no. No, no. Alright? This is a big no-no. Okay? The back EMF with the back EMF, alright, will make this current from the inductor to this way. It's bad arrow again. Okay? Please do not judge on my drawing. It's just, I don't know why. Okay? But besides that. So, now it makes the LED light bulb flash. That was the flash that, from the inductor, when C1 was opened, it creates that flash. But the magnetic field is so weak that it just decreases over very fast. And that's why you just see a flash and just comes back and then stops. Alright? Now there's no current. All the electrons and the current is stopped. So that's how it works. That's how the inductor, I don't know why I forget that word, but the inductor, alright? Try to remember that. The inductor. Also me. That's how the inductor works, alright? So I hope you enjoyed my explanation and saw this experiment. And if you can understand that, then that's great. If not, then it's okay. You can ask an adult to help you understand what I'm trying to say. So, besides that, I hope you enjoyed it, and I'll see you in the next experiment. Bye!